Hi everyone, my name is Eli and I'm presenting my car forecasting project. In today's economy, not many people can afford to buy a new car, so there is a massive market for a used car. Unfortunately, there is no perfect source where you can check the car value and price. In my project, I will try to solve this problem. The goal of the project is to predict the market value of used car on an auction, which can help both buyers and sellers to buy or sell the car and eventually save some money. The data has 25,000 values that was used in this project, and it was downloaded from a Mannheim website. Unfortunately, it's not available for public use. As you can see, it has multiple features like year, make, model, subseries, and other. First things first, it is important to clean our data so we can have a juicy and good results. The data cleaning procedure was done in 4 steps. The step number 1 to clear data was to remove unnecessary features. I decided to remove features like power steering, power brakes, air conditioning, since the majority of modern cars already have them, and it will have the small or no effect on a future model. The second step was to drop the columns with missing or NA values. The third step was encode the categorical values like a make, model, and color using the label encoder. And the fourth step was to drop outliers. After data cleaning, I decided to introduce the dummy variables for features like engine, body, and others. For example, if the engine have 4 cylinders, the dummy variables would look like binary code like 000100, and each column will have that value. I did use a label encoder originally, but the model performed not that well, so I decided to use a dummy variables, and it did improve the accuracy. And I believe if you have an option to use a dummy variables for data that can be scaled, you should definitely use it. After that, I just normalize the data using a standard scaler that was reducing my mean and skewness of my data. In the main part of my project, I decided to use several machine learning techniques like random forests with cumulative features importance optimizing, rich regression with lasso feature optimization, and k nearest neighbors with the elbow method. Before build my random forest model, I checked the importance of each feature compared to the price. For example, odometer is 0.31, engine is 0.16, and we can see that on a graph as well. After, I built cumulative graph to determine the 90% of the features for a odometer, engine, make, year, and engine. So the rest of the features are kind of useless. After 90%, they have less effect of only 10. Including only these 7 features, I built my random forest and accuracy was good. It was 84%, and the mean square error was $4,700. which is not that bad if you buy the car for like $23,000 or $30,000. My next approach was the ridge regression, but before I checked the data importance, that we used a different approach, that an elastometer which uses shrinkage in the central point, similarly of the mean value, and based on alpha determines the features importance. As you can see, those are all the lines and features, they come together. To make it more simple, I decided to build a graph that basically shows the feature importance using the ridge model. As you can see here, it has the highest weight, has the like plus $5,000, and the engine has a negative weight. Engine 4 has a negative weight minus $2,000, and there are some values that I have little or no effect. And it's actually different compared to a random forest numerical features we used before. If we come back really quick, see here we have year, engine, and year. There it was odometer, model, make, and engine 4. In this slide we see the ridge regression with the lasso, and the performance of this method was 51.5%, and the screen mirror error was 8200, sorry. You can see that it's performed okay. I'll come back to really quick. See in a graph you can see the prediction. For example, the car was predicted for $32,000 and the actual price was $43,000. And here it's kind of performed well. It was predicted for $12,000 and it was actually about $12,000. Here it predicted horribly. The car value was 0 and it predicted that is minus $9,000. I don't think any auction will give you a car and also give you $9,000. Last machine learning algorithm I used was the key nearest neighbors. First of all, to determine the k-split, I used the elbow method to decide which was the best. Here's the outcome of the errors, and as we can see, the split of 4 and 5 has the lowest error and a kind of fast. After that is actually getting worse and worse, and the speed goes higher, so we definitely should use between 4 and 5 splits. I decided to use 4 splits, and that's the result I had. The accuracy is 631, which is absolutely horrible. For example, here the predicted car value was $4,000 and the actual sold price was like $45,000, $42,000. And the rest you can see that did not perform that well. Here's my final results. As we can see, the random forest performed the best with accuracy at 85% approximately, and the key nearest neighbor performed the worst with error rate up to $9,000. I don't think your friends will be happy when they will use the model with a range of $9,000 error. In conclusion, I'm okay with my results in a random forest. I hope for the best, but I think the model could perform much better if I might have more data, maybe 300,000 or about a million, especially for key nearest neighbors, because I would have less problem to determine the key nearest neighbors with more data. Overall, Thanks everyone.